In this lecture, we will discuss about the DFT as linear transformation. In the previous two classes, we have discussed how to determine the DFT, how to determine the IDFT. The DFT maps n number of discrete time signal x of 0, x of 1, x of 2 up to x of n minus 1 into n numbers of complex variables, capital X of 0, capital X of 1, capital X of 2, capital X of n minus 1. The output, which is a n cross 1 matrix, can be computed by the matrix multiplication of a n cross n W matrix with the n cross 1 input signal. Let us understand how this can be done. So basically for that, we need to write down the formula. We need to write down the relation of discrete Fourier transform. As we know, x of k is equal to summation n is equal to 0 to n minus 1 x of n e to the power minus j 2 pi kn upon capital N. The same DFT equation can also be written in the form of twiddle factor as summation n equal to 0 to n minus 1 x of n wn to the power nk, where e to the power minus j 2 pi upon capital N is wn, which is known as twiddle factor. Now let us find out the DFT result for different values of k from 0 to n minus 1. So the first value will be capital X of 0, where k is equal to 0. This will be x of 0 wn to the power n is 0 here and k is 0 here, plus x of 1 wn to the power n is 1 here but k is 0 here, plus it will go on and finally it will be x of n minus 1 wn to the power n is n minus 1 but k is 0. Similarly, the second value of DFT will be x of 1, which is x of 0 wn to the power n is 0 but k is 1, plus x of 1 wn to the power n is 1 but k is 1, plus x of 2 wn to the power n is 2 and k is 1, plus x of n minus 1 wn to the power n minus 1 into 1. Similarly, the third sample will be x of 2, which is x of 0 wn to the power n is 0, k is 2, plus x of 1 wn to the power n is 1, k is 2, plus x of 2 wn to the power n is 2 and k is 2, plus x of n minus 1 wn to the power n is n minus 1 and k is 2. In the same way, we can find out the value of x of 3, x of 4, x of 5, and finally we can compute the value of x of n minus 1, which is x of 0 wn to the power n is 0, k is n minus 1, plus x of 1 wn to the power n is 1, k is n minus 1, plus x of 2 wn to the power n is 2, k is n minus 1, up to x of n minus 1 wn to the power n minus 1 into n minus 1. So in this way we can expand this particular summation for different values of k, and we can get the DFT result. Now these above equations can be simplified and can be written as capital X of 0 x of 0 wn to the power 0 plus x of 1 wn to the power 0 plus x of 2 wn to the power 0 plus x of n minus 1 wn to the power 0. Capital X of 1 will be x of 0 wn to the power 0. You can see here this is wn to the power 0 plus x of 1 wn to the power 1 plus x of 2 wn to the power 2 up to x of n minus 1 wn to the power n minus 1. Next is capital X of 2 will be x of 0 wn to the power 0 plus x of 1 wn to the power 2 plus x of 2 wn to the power 4 plus x of n minus 1 wn to the power 2 into n minus 1. It will go on, and finally we can write down x of n minus 1 will be x of 0 wn to the power 0 plus x of 1 wn to the power n minus 1 plus x of 2 wn to the power two into n minus 1 plus x of n minus 1 wn to the power n minus 1 into n minus 1. Now these above equations consist of the outputs, inputs and w function. So the above equations can be written in the form of, or can be mapped on a matrix as capital X of 0, capital X of 1, capital X of 2, capital X of 3 up to capital X of n minus 1 is my output is equal to W matrix wn to the power 0, wn to the power 0, wn to the power 0 in this row, and wn to the power 0, wn to the power 0 in this column. So first row and first column has a power equal to 0 multiplied with the input discrete time signal, small x of 0, small x of 1, small x of 2, small x of 3, small x of n minus 1. Now this can be filled up with wn to the power 1, wn to the power n minus 1, wn to the power 2, wn to the power 2 into n minus 1. This will be wn to the power n minus 1, wn to the power n minus 1 into n minus 1. So in this way we can design a matrix which contains the output function, the w function and the input function, and this output can be calculated or computed by the multiplication of this w function with the input. So basically DFT as linear transformation is frequently asked question in the semester examination, either in the form of short note or in the form of long questions of 8 to 10 marks.